Hi, everybody. In this last section on chapter 3, we're going to look at modeling using variation. So first we'll start with direct variation. If a situation is described by an equation of the form y equals kx, where k is a non-zero constant, we say that y varies directly as x, or that y is directly proportional to x. So both of these words mean this, or these phrases mean the same thing. The number k is called the constant of variation or the constant of proportionality. And again, it's the same thing. I feel like personally, probably the constant of proportionality is maybe what you've heard more. I feel like that's taught often in middle school or high school, depending on where you go. But it's the same idea. So variation and proportionality, basically the same idea here. This is actually a special case of a linear function where m is equal to k and b is equal to 0. So if you have direct variation and you just have a straight linear function, so no squares, no cubes, things like that, then it's just a line with positive slope in most cases. So if your k is positive, then you would have that positive slope here. So how do we write variation problems? Well, the first thing you're going to do is write an equation that models the given English statement. That's the hardest part. What will happen is you should be given enough information to plug in and solve for k. So we typically start with something like this, and then we're going to be given some information where we can actually plug it in and solve for k, and then we rewrite our equation with the k value in there. If there is another question that follows that, then we can now use our equation to solve. So let's actually try this. I think it'll be easier to see with some examples. So the volume of blood B in a person's body varies directly as body weight W. A person who weighs 160 pounds has approximately 5 quarts of blood. Estimate the number of quarts of blood in a person who weighs 200 pounds. So it really is sort of like an idea of a proportion, right? Or a comparison with two ratios in a way. So this is just a different way to think of it. So if you see those words varies directly, then that is telling you that your basic formula is y equals kx. So that's how you're starting. Now you need to find the k. The y and the x are supposed to be in your equation, but the k is not. K is a number. So what happens is you should have enough information to fill that in. The other thing you may need to do is to change your variables. So here we're using y and x, but actually the problem asks us to use b for blood and w for body weight. So I'm going to change this over and I will use b for blood. So b is like the y, where that's what's varying directly as the body weight w. So kw. And then the other thing I'm told is that a person who weighs 160 pounds has about 5 quarts of blood in their body. So 160 pounds and 5 quarts are associated together. So we're going to plug those in. So the blood is 5, the weight is 160. So you should have some sort of pair of information that's given to you, and then you can plug it in and use that to solve. So I can simplify this, dividing these both by 5, and I would have 1 over, and then 160 divided by 5 is 32. So your k value here is 1 over 32, or you can also put it as a decimal. Which is like this. Now, this is an exact decimal. It does come out completely in end. I would say as a personal preference, I tend to like the fraction form, but your book for this one uses the decimal form. So you can really use either. I would just be careful and make sure that you use all decimals. You don't really want to round your k value or it will cause your answers to be a little bit off. So what we do now is we just plug this k back into our formula. So it becomes b equals, like I said, I tend to like the decimal, but your book is using, I like the fraction, but your book is using the decimal. So I'm going to stick with what the book's doing. But I plug that back in. So now you have an equation. So this is your equation. And now we can use that to actually answer a problem. So estimate the number of quarts of blood for someone who weighs 200 pounds. So here I'm trying to find the amount of blood for somebody who weighs 200. So now I have an equation that I can go ahead and plug one variable in for. And I can simplify here. And what I get is 6.25. So a person who weighs about 200 pounds has about 6.25 quarts of blood. Sorry, for pounds, I should abbreviate better, right? So pounds is actually LB or LBS. I was just abbreviating PD and being a little lazy there. But the formal abbreviation for pounds is LB for pound or LBS for pounds. Okay, so I should change that here instead. Okay, but your answer is going to be that 6.25. All right, let's try another one. So the distance S that a body falls from rest varies directly as the square of time t of the fall. Now, this one's a little bit differently. We do see varies directly, so you can kind of think of that y equals kx idea here. We got to be a little bit careful. We are changing variables, so we're using s instead, and we're using t, but it's not just time t. See how now it says the square of time t? So instead of just using an x here, we're actually squaring it. So it should look like this in our formula. Okay. So be careful for those little changes. So not every set of variation has to be linear. Some of them are going to have exponents. So we do need to be a little careful there. Now you should have some piece of information that we can plug in. So we're told here that if a skydiver falls 64 feet in 2 seconds, how far will they fall in 4.5 seconds? So this is your pair of data right there. So when S is 64, my T is 2. Don't forget that's being squared here. So this becomes a 4. So I'm dividing both sides by 4 because it's actually 4K. And then we get our K value of 16. So our equation becomes S equals 16T squared. Now we can use that to answer the question. So I want to know how far will they fall in 4.5 seconds. So I know my T value here. I plug in that T value. Again, make sure you square it first. In this case, so you get, let's see, 20.25. And when you multiply that by 16, you get 324. And this is in feet. So in 4.5 seconds, they fall about 324 feet. So what I want you to really pay attention here is that when you hear that word directly, you're multiplying. So directly, oops, let's try that again. You are multiplying with the K. So something is being multiplied with the K when we vary directly. Now, there's also inverse variation instead. So if a situation is described by an equation of this form, again, K is a non-constant 0. So here we say that Y varies inversely as X, or Y is inversely proportional to X. Sometimes you'll hear the word indirectly as well, but usually we say inversely. And K is called that constant of variation. Do note that the inverse function is actually irrational, right? So before I mentioned when you hear that word direct, you want to think about multiplying. So when you hear that word inverse, you want to think about k divided by the variable, whereas when you hear direct, right, we just said you have k multiplied by the variable. Okay, so inverse, you're dividing with that variable, and direct, you're multiplying with that variable. So that's a really important change in that keyword here. Okay. So let's do an example here. So when you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can, and this decrease of pressure causes the volume of gas in the can to increase. Because the gas needs more room than is provided in the can, it expands in spray form through the small hole near the valve, not the value, near the valve. So in general, if the temperature is constant, the pressure P of a gas in a container varies inversely as the volume of that container. So again, if I hear inversely, I'm thinking about division, right? Inversely, think about division. So you have y equals to k over some variable. Now, again, that variable could be squared or something different, but that you have that basic setup. Okay. Here, I don't see any words that imply that we are squaring or cubing or doing anything like that, or using roots or anything, but I do have a change in variables, right? So really this should be P equals K over V instead. All right, so let's see what we know. We know that the pressure of a gas sample in a container whose volume is 8 cubic inches. Now that cubic inches here is just a unit for volume. Volume is always in cubic units, just like area is always in square units, for 12 pounds per square inch. So that's one pair of data. So when the volume is 8, the pressure is 12 pounds per square inch. So I'm going to use that to set up my formula. So 12 equals K over 8. And then think about solving this. We would multiply both sides by 8 here. And we get that K is equal to 96. So our formula would actually be P equals 96 over the volume. Now, if the sample expands to a volume of 22 cubic inches, what is the new pressure? So now I know the volume and I'm looking for the pressure. So 96 over 22. We can divide those each by 2. You have 48 over 11. 11 goes into 48 4 times, which is 44. So I have a remainder of 4 there. So the pressure is 4 4/11. And then use the same units, pounds per square inch. So again, what I really want to drill home, and I keep repeating myself because this is something that students make mistakes on a lot with this section, is when you hear that word direct in your formula, you are multiplying with K. And when you hear that word inverse, you are dividing with K. Okay, so K is still always on top, but that other variable is going into the denominator. Okay, so it's a really important clarification here. And a lot of times as we're reading through, particularly if the examples are kind of mixed up, you may miss that little key word. So if you see direct or inverse, those give you 2 different setups in your equations. And then after that, look for other things. Are you squaring anything? Or sometimes we'll see roots, etc. So there could be something tweaked, but overall, that's your basic setup. Notice in all these examples too, we're not adding or subtracting anything. So they're as basic as we can get for this style.